All right. The demo gods must be with us. Yes. Unless, can you guys hear me just fine? Yeah. Mike. All right. Yeah. Just make sure. Yeah. Like, no, not me. All right. Cool.
Are you gonna start singing now?
I actually do love karaoke. If we have time, we'll do it. All my favorite songs are sad songs, though, so you might get annoyed about that. All right. So, hey, welcome. My name is Kush. I'm a software engineer primarily. I've been building software for like 12 years and stuff professionally. And my background, however, is like very sort of more creative oriented, like design, film, game dev, stuff like that. But software has just always been very interesting and awesome to me since like I was in second grade. So just kind of software in second grade is different than programming in second grade, but you get the idea. And so I just love it. And AI has been like my latest focus in the last couple of years, really diving into NLP, computer vision, computer graphics. That was the about me slides, so I'll skip that one. So yeah, AI. I'm going to be talking about open source AI, and because I have like almost 40 minutes to talk, so I'm going to go slower now and not talk as fast. So AI, it's a large umbrella. There's lots within it. I feel like the part that I focus on a lot, the part that I think you should care about, is not AGI, God AI, like what these systems that can solve anything, and these systems that will replace us, the sort of general AI conversation that goes around in at least social circles, but rather AI as a tool, a very small, very perhaps robust, although robust is not a word you generally hear with AI, a small tool that you can use to do small things, or even big things, but in a very constrained capacity. And so that, an example of that would be, for example, data-to-data conversion. So think text to speech. What is that? That's voice synthesis, right? So if you can actually have a bot talk back to you a message. For example, if you're hard of vision or whatever, you can actually hear back a message, text to speech. That's the modality, taking a bit of text and converting it into actual understandable speech. That's something that generally speaking you would find a human doing, reading off a text. But now we have AI systems that can sort of imitate that or do that to some extent. That's an AI capability that we now have under the umbrella of AI. Another thing would be text to text. What does that mean? Translation, for example, going from French to English, English to Spanish. These are things that generally speaking before you would have had translators do it, and now you have AI systems. And I say now, sort of liberally, it's been around for a while, but that's part of AI. Then there's text to video. You've seen Sora and examples like that where you have entire GIFs or movie clips being created with that. So you have, all kinds of other modalities. So whether you're going from text to text or text to speech or anything else, these are the kind of examples of AI. Small capabilities, not necessarily something that you tell a task to go shop, groceries for me, but rather that small constraint thing that I'm most interested in. Because I'm a developer, I'm also a designer, but that's like, even when you're designing systems, you want to understand what things now you can take for granted and just build with them. So that's what I'm going to focus on. Already way too much time on this slide. So within AI, because like I said, my interests are in computer vision, computer graphics, and NLP primarily. I'm going to focus on NLP for this talk, because that's kind of the stuff that I prepared, and there's not enough time to cover everything, and I don't have very clever things to say about the other stuff yet anyway. So what is NLP? NLP is the field in which you're generally speaking dealing with language, natural language. Natural language being fuzzy human language. If you know the George Carlin bit where language is used in a very funny way by humans all the time. We will never say exact time. We'll say, in a second, or, in a while, or soon, and all these things. We always use different words for different same things, just because that's humans. We always, have a fuzzy sort of sense of language. And so natural language processing is a field where we're trying to understand, through in computers, language that is generally speaking not quite a command. So before you would have systems that you would be like, all right, robot, do this, and you have to say exactly in this way. Add this number to that number, or a function call, for example. Call the function add. Parameter 1 is A. Parameter B, second is B. But now your systems where you can simply ask in natural language, and you can get something, be done automatically. So within natural language, and there's like a lot of history that I can go into just because I love it. Like this is an old field, like 60 years or more. There's this linguist Noam Chomsky who did a lot of work on like the early days of establishing robust grammar-based language modeling. But then, now in the last sort of at least 10 years, almost 10 years, Transformers, this paper that Google released, or scientists at Google released, really sort of pushed the boundary on what deep learning can be used for in this field. And so now you have a lot more large big data systems that are taking care of this task, as opposed to sort of here's how language works. Verbs come after nouns come after adjectives and stuff like that. So within NLP, I'll talk about two artifacts, which are large language models and embeddings. And embeddings, I'll do it towards the later part of the talk. Very cool concept. I only found out about them after the AI hype started, but it's not a new concept. It's been around for a while. Give me a second. I'm just going to drink some water. So large language models. What are they? How do they come out to be? So if you heard the application ChatGPT, which I'm almost certain all of you have, that is based on, or that the core technology behind it is a large language model, the GPT-4 model. That is a large language model. It's the brain of the operation. ChatGPT itself is an app, like a mobile app, Swift app, or whatever, right? So as I headed to this thing and talking about what LLMs are and like really sort of trying to reveal the core technologies behind it, I want to kind of survey the audience just to understand who I'm talking to. Are these mostly developers? Are they designers? Are they artists? Are they mostly PMs? Non-technical people. So I'm going to sort of say, how many of you have are developers in your profession? All right, lots of developers. That's great. I'm going to get technical a bit. How many of you are like designers? All right, well, I was expecting more designers. Well, I'm a designer too. Two of us in this room. How many of you are like artists of some kind? Beautiful. And what did I not cover? Like, yell out something like PMs, or what did I not cover?
Yeah, founder.
Founder, all right. Beautiful. Yeah, so basically people who are more business-minded are trying to build ideas. They come up with something and then say, you know what, I'm going to implement it. And that also requires a sort of understanding of the ingredients that you're working with. I have concrete, I have computers, I have developers, that's the ingredient as well. I have designers, so I can hire them all. And now you have AI. And what does that mean, AI? LLMs, or embeddings. So I'm going to talk about these tools in a way that you now understand what they're really made with. And so now you can sort of rely on them as a tool in your arsenal when you're ideating. So LLMs are basically this artifact that's produced after a significant amount of data is thrown at it in a training process, in a process in which it sees a lot of text on the internet, and it tries to compress that into a much smaller, let's say, file. And an example of this would be the latest Llama 3 models, which are these sort of LLMs released by Meta as open source, which we can download now and run offline locally and so on. Those models really saw 15 trillion tokens, and tokens are basically like parts of words, because there's hundreds of thousands of words, but if you just combine half words together, you can get like a lot of the way there. So tokens are basically like a word like highly would be, high is a token, and then ly is a token. Ly can be used in a lot of places, and so can high. So tokens are basically just words, but smaller. And so this model, the Llama model, saw 15 trillion tokens, which you can imagine is probably the majority of the public internet. And it saw that many tokens, and it compressed it through a training process, which is called pre-training for some reason, and compresses it into, like, in the case of Llama 3 8 billion model, a few gigabytes, which is insane. The entirety of the internet compressed in a lossy way, so you lose some information into a few gigabyte file, which is incredible. So now you have this sort of alien artifact, this few gigabyte file that you can just go, off into the woods without any internet, and you can prompt it to find all kinds of incredible information about the world, or at least as the internet knows about the world, in a text form. So how incredible is that? I feel like as soon as that sort of came into the face of all of us, like developers, like, oh my God, this is actually a thing that we can now use, and offline, that's an incredible thing. And we're moving more and more towards smaller models that can be compressed and run just on device, on my phone. I'm always building apps on my phone, like notes apps and calendars and whatever else, and I have AI doing a lot of sort of, data processing on that, all on device, which means complete privacy, complete local use, and that's where the open source aspect comes in, and I'll talk about it in a bit. So that's really the core thesis of like what's going on here, that these are files that are created with a lot of data compressed through a training process, which takes a lot of compute, which means a lot of money, and that's why the only people that have been really able to do it is these big companies who have, hoarded the wealth and they got the domain to do it, because governments don't have the ability to do it, and people certainly don't have. I couldn't do it. just because of money, not because I can't do it. I probably can't do it also. But either way, point is, whenever these people launch it, I'm happy because now I can use it locally. So like I said, LLMs are the artifact that are produced. Then you can now use them to generate all kinds of interesting responses, like an alien artifact you're poking at. Let's get a little bit into how they're trained, at least in the case of LLMs, because this is not the only concept. Just so you guys understand, this is the one that's most popular. This is the one that seems to be quite useful for all kinds of interesting tasks. But for example, the way LLMs are trained is you would say, here's a, actually just a sort of preface to that, before I get into it, is they're literally trained on the public internet, which means us. It's our data. It's like fan fiction blogs you guys wrote. It's Stack Overflow posts that I'm sure a bunch of you people like answered and asked questions and participated. So all of us for the last many decades participating in the conversation, actually contributing to the public internet, we are the reason why these things exist. Big data is the fundamental reason, which is why, and forgive me for swearing, when these fucking companies try and pretend as if like we just trained this model and now we're going to keep it private behind an API, that's a joke, because it's our data. We contributed to it. Humanity contributed to it. It's a reflection of us. In fact, one of the ways to think about LLMs is like surveying the zeitgeist. So if you ask it a question, it will not give you the right answer, but it'll give you the most likely thing that it saw on the internet. So in some ways, it's a great way to find out what's the most common thing the LLM believed after seeing 15 trillion words on the internet. And so anyway, that's just a side point saying like this is why open source matters. It's why all this should be free, including Google Maps taking pictures of the entire planet and then keeping it behind an API. Shouldn't be done that. But that's a separate point. So the way that these things are trained is you would give it like a lot of text, like this paragraph in a technical blog. Say if you're interested in diving, and it'll say predict me the next word. And if it come back with deeper, especially after diving deeper seems pretty likely. But also after all this context, great, move on to the next word. If it doesn't, then in the training process we'll say, you know what, you didn't quite get it right. I'm not going to tell you exactly the word you should use, but I'm going to give you a loss sort of attribute which says that go in that direction or go in this direction, and we just keep going through the process. This is like a slight technical information. It's not actually in the real world how it works, but at least you get a bit of a sense of how it is trained. It's basically literally just a process of guiding the model to be better at it over 15 trillion times. In fact, it's more than 15 trillion because that's just the data set. You do it multiple times just to make it better. And so that's not the only way that this works, or the AI has been explored. There's also something called, so this is basically autoregressive. Autoregressive meaning like it sees one word, and then after that it sees the next one. After that it sees the next one, or tries to guess the next one. Then there's another process called masked language modeling. And there's models like BERT and so on, where you would say, here's a piece of text, and I've actually blanked out this word. I blanked out that word. And just tell me what that word is. You guys generally don't use that model, at least not in the real world as you interface as consumers. But that model is used in the embeddings concept that I'll explore later. And so that's like my point being saying it's a lot broader, the field, than just ChatGPT or the LLMs that we use and even the LLMs they're talking about. And so if you are actually research minded, there's a lot to contribute, a lot to ideate, and you don't just have to be a developer to contribute into this field. In fact, of course you don't. So anyway, that's a lot of time on this slide. So let's get a bit more interactive. This whole presentation, by the way, is actually like just an app that I built. So everything is live. Every call that I make, everything that happens is an actual AI model being called, all locally. In this case, not on my laptop or my home machine, just because this laptop, I didn't want to risk the demo going south. Plus my home computer is more powerful, and so it's going to be faster. So let's talk about the fundamental artifact, the one that I talked about, millions of hours of compute, hundreds of thousands of dollars spent to produce. This is the base model. This is the one that saw 15 trillion tokens, and it created this compressed file. Base models are models like Llama 3, 8 billion, and I'll talk about that specific name in a bit as well. So it'll do something like this. The way that you interact with it is give it a prompt, and it comes back with a completion. And generally speaking, it's just coming back with one word, but I'll talk about how that works. So if I say once upon a time, it's going to say there was a little girl who lived in a big house. Cool, sounds good. That's what things likely. Okay. Well, actually, if I say once upon a time again, same answer. Well, what's strange? If you've used ChatGPT, you're wondering that's not how it works. It always gives me a different answer. Well, no, ChatGPT is a modification on top of it, and I'll talk about how that works. Generally speaking, it'll always give you the same answer for the same prompt, because that is the most likely thing it thinks. After once upon a time, comma is the most likely thing that this model thinks, this specific one. After that, there is the most likely word that it thinks. And so, literally always, deterministically, it'll give you the same answer. How you modify it, I'll talk about it in a moment. So if I go in a land far, far away, there was a kingdom called, same answer, and I just keep running it again, and it'll just keep giving me the same answer always. So let's get into the how it's working just very quickly. Like I said, only one word at a time, one token at a time to be more precise. So if I say, give me the next token, I just hit enter, it gives me the next token. It was a comma. What did I do? I copied the comma, I pasted it over there, I do it automatically, and then I say, give me the next one, there. I copy this, I put it there, give me the next one. And so really all that's happening is these LLMs always only give you back the one token, the one word. And then I just happen to copy it, the one that it came back, put it back into the prompt, and ask it to do the next word. That's all that's happening. So if you read like arguments and debates online about like, oh, these are just stochastic parrots, they just give you one word, they just autocomplete, there is some truth to that. I myself am not much of a believer in the intelligence of these models. I think they're very useful, so I use them, but I wouldn't, have it, I don't know, do my tax or something. They can be used in small capacities to do interesting things. So, it'll just keep doing that, one word after that. And I thought of try to find a way to demonstrate the temperature concept and the variance, which I'll get into in a moment. So what happens if we have this thing, and we're trying to actually get back a different result? So it says, once upon a time there was a little girl. Let's say once upon a time there was a massive, let's see what it says now. The temperature is 0, so it still will always give me the same thing after massive. So massive, there was a massive 1,000 pound, 10,000, okay, you just keep going. There's a tiny, what happens to tiny? The tiny island. All right, that's, okay, whatever. Thought of a cool example on the way here. I was just trying on the cab. Let's see, it was a dark and stormy. Is this not the one? How do I do this? Maybe the next slide? Yeah, okay, that's not. So there was an example here, can't find it. In any case, the field of defense against the dark arts, for example. Oh, sorry, what am I doing? I didn't understand the concept. So once upon a time, it's always giving us, or it was a dark and stormy. If I ask for it, it'll say night. The rain fell in torrents. But if I now say, actually, don't give me the most likely word. Give me something that's likely, but not the most likely. And how that works, I'll talk in a moment. That'll happen when I modify the temperature. Temperature goes from 0 to 1 generally, and you say, just be very, loose about the next completion. Don't just say what the obvious thing is. So now it says once upon a time, semicolon, a wizard was in the foreign land. All right, it's a pretty interesting one. Let's ask it again at the same temperature, which is like, just don't give me the obvious answer. It'll give me a very different answer again. There was a man called Todd, right? So the temperature, what it's doing, just to get a bit into the weeds, because some of you are developers here and you'll understand it. What's really happening when you ask for the next token here is not actually it giving us a token. What it's giving us is a probability distribution over all the tokens. So it has a vocabulary of 30,000 words. And that means that it only understands those 30,000 words. Now they happen to be words like hi and ly and so on, so it actually does understand basically all words possible and numbers and so on. But instead of giving us the there, it actually gave us a whole probability matrix with the word there, the word zebra, the word mask, all these words are in there. Happens to be that there has the highest fractional value out of this. And so that is how we know to pick that one. So when the temperature is 0, it'll always just sort of say, pick the first one in that list, the one with the highest value, that was there. But if I happen to say, actually, just don't pick the highest likely, but instead say a temperature of 7.75 might mean in a certain kind of a calculation that actually pick me the 25% of the distribution. So let's say the 10% is the most likely, 5% is the second most likely, 5% then you add it up till 25%, discard them all, and then between them, give me the random choice. So it's saying, you know what, give me something else. Now it's saying in the early 15th century. Let's say in the early 2009, Google announced, so it'll just keep changing it based on whatever you're giving it. But hopefully that gives you a bit of an intuition how temperature works and why when you ask ChatGPT, and I'll address that in a moment, when you ask ChatGPT, how does it come up with a different answer each time? It's because there is a dial that they have secretly behind the doors. It's not that secret, but where they say, never answer deterministically. Always just vary the answer a bit. So you might not get the most likely answer. Sometimes it might just deviate just because it's being told not to answer in the accurate way. But just quickly on that, you might wonder, well, okay, if I change the temperature, am I just not asking it to lie? So how is that even useful? You would always keep it to 0. Well, there's a reason for that, because information that is very obvious, it'll still stick to it. It's just too hard to deviate. So, for example, if I say the field of defense against, you guys all know what it's going to say, defense against the dark arts. All right, yeah, that's pretty much what it said. But even if I go ahead and say the field of defense against and a very high temperature, which is all the way cranked up to 1, it will still just say the dark arts, because it's just too obvious. Defense against simply is going to be followed by the dark arts, and this is the field in Harry Potter if no one knows what this is. So it will hold on to things that it really thinks are most likely, and so that's why you can actually still crank up the temperature, get the creativity going, but it'll still hold on to basic facts like highly will be followed by recommend, and so on. Anyway, oh, you had a question, please.
Yeah, I was picturing this distribution you're
Uh-huh.
talking about, and the temperature being at 1, and wondering if like standard deviations into this when it's trying to select like the most left field, like a 1 temperature. And I guess the direct question is, the result's still coherent, right? The temperature wouldn't go so far that like it wouldn't even make sense anymore. Like the model just wouldn't allow that.
Yeah. So exactly. So as I was covering after, there is the likelihood of certain words is too strong that at least the temperature at like 1, maybe if it is set to 100, maybe it will just basically just put out like hash, comma, whatever. But I think the point is that because of the training process, the things that are most likely will still say. And the word standard deviation, I'll just be real, I'm not a mathematician, so I don't even know what that word really honestly in detail means. So I'm too dumb to answer that question. So maybe Nurain is smart enough, or maybe some data scientists in the room will be able to answer that. But generally speaking, I understand how it's applied, and it is that you're able to vary the most likely word to be a little less likely, and you get a lot of creativity out of it. So let's get into doing something more useful with it, in-context learning. So in-context learning is a concept about where you're saying, okay, this model has a certain bit of knowledge that it has. Let me guide it further to be able to actually do better at the task that I want. So if I say, translate the following sentence into French. All right, it's a beautiful day. Let's see what it comes back with. Remember that these models are basically trained over a large corpus of the internet, but that really means they've been trained over websites, documents, lots of just posts, not really over question answer, right? So what is it likely to do? If I hit enter, it's going to say, start with CS and add the appropriate. It's actually guiding. It's like just coming up with the whole recipe. It's just trying to finish the thing that I said. Translate the following sentence, start with CS, and add the appropriate. So it's just like try to make up a document that exists somewhere in the world, right? Some understanding. If I ask it again, now it's saying, read the following sentences and translate them. It just keeps making stuff up. It's not actually answering the question, because it's not trained to answer questions. It's simply trained to predict what exists out there as a document on the internet. So how do you get utility out of it? Well, one way that you can do that with these base models is to say, guide it. Translate the following sentence into French. English is this, French, colon. So this might be a document that exists in the world, and if it sees French, colon, it's very, very likely the document was completing the actual translation. So now if I ask it, it'll actually go ahead and say that. And don't worry about whatever it's saying extra at the bottom. I'll cover how to remove that in a moment. But so that thing is basically us using in-context learning as a concept to guide the model towards giving us what we want. So in this case, we're saying, give another example. When I say English, do this. When I say French, when I have French colon, you'll give me the translation. So now here's another sentence to it. It's even more likely to get it right because we really guided it. This is a one-shot. If you've heard the word one-shot prompting, we're giving it an example. That's one shot, one example. We can do multiple examples, or in this case, we're asking for a sentiment classification. Again, it tried to give me code, so I didn't ask for code. I just asked for the sentiment of the sentence. So actually, I'm going to say sentiment colon. It's much more likely to get it. But maybe I don't want neutral. Maybe I want positive and negative only. So I'll say positive, negative as an example, and I'll ask for it, and it actually gives me negative, right? So same thing with all these examples. And by the way, this was a massive insight, the idea that we can actually ask it just things in natural language or pretend as if it's a document out in the world, and it'll just complete it as if it's doing the task, and it's got that brain capacity to do it. That was the key insight. That was in 2020s, explored by OpenAI. Other people as well, but they published a paper called Language Models Are Few-Shot Learners. It's a great paper. You guys should read it. This example is from that. But they really explored the idea that these models, these alien artifacts, if you just pretend as if it's a document in the world, the thing that you're trying to do, it'll basically answer the question. Because if after all this knowledge that it's compressed, it just understands certain things. That's why it seems human, because it'll be able to, at least to some degree of capability, be able to answer great questions, or answer questions in a great way. So you now understand how we can sort of pretend and guide it towards actually getting useful information out of it. So, for example, if you ask like how many planets are there in solar system, it'll come back with a big answer. All right, this is good enough. You gave me an answer. Again, we are not really given the Q&A format. But if I say question, how many planets, and then answer colon, it's even more likely to give it. In fact, now it gave me a number. Sometimes it doesn't give me a number though. So let's actually guide it further. I'll say generally I want a number, so I'm giving it 7 for the other question. So now it's even more likely to give me an actual number back. If I say, okay, so yeah, that's how. And so you saw like how I'm saying question and answer, and that guides the model. Well, I can also just say instruction, response. So I just said instruction is this, response is this, instruction is this, response is this. And so now I can understand, so whenever it sees the word response, it should probably give me the response to that question. Because again, it's just learning that in the context of this little prompt, this little moment, that it should do that. One quick point about that, by the way, these models are all what we call stateless, and that means that these models are not actually learning anything, like free from each call to another call. Whenever you run them, that happens in isolation. No one, unless you're calling an API like OpenAI, in which case you're sending them your private data, they'll maybe store it. But if you're running it on your laptop or anything, it's just that one moment, the text went into memory, got computed, came back, the model did not learn anything. Next time you ask it a question, it's like brain wipe, fresh memory. And so you have to give it that memory, and I'll talk about how you do that. But that's why we have to teach it in context right now, that instruction response is the way that we want answers. So by the way, you're seeing below all this like extra information. How would you get around it? Like, would you have to like maybe look for the word instruction colon again, and maybe then you can just chop out the text before that? Yeah, that's one way to go about it. Or you can say instruction, in brackets, and then slash response. That could be a pretty clever way to like know, what, the user is very unlikely to type slash response in like their question. So actually, that's a clever way to, whenever we see slash response in the answer, at that point we say, hey model, stop, enough. I got the response. Good, homies. So I can just say, so that's how you work, right? So now you can just actually crop out the answer at the point that you get enough information out of the model. So in that way, we have various templates, various prompt formats that people came up with to be able to guide the model, right? The one that got really popular, this is last year after the initial Llama model got leaked. There's lots of like drama around it, where they basically like, hey, there's a new model out, use it. But they're not going to give it to anyone, and then someone leaked it, and then people were very happy about it, and then people started experimenting. It was like a real awesome time. And then people are like, okay, now that we have it to play with in our homes, let's try cool things. And one of the formats that really people started to adopt in trying to instruct the model was this thing called the alpaca prompt format. And that's basically, they said, I'm going to say below is an instruction that describes a task, paired with an input that provides further context. Provide a response that appropriately completes the request. And then we say # instruction, convert the Celsius to Fahrenheit, input temperature in Celsius is 15, and then response, then we leave a blank line, and the model tries and completes it. And then, so you can see, it's basically the same concept that I explained to you, but this is more a popular format people started to follow. And there's another purpose of it as well, which I'll talk about in a moment. Here's another example of using, triangle brackets, IM start, triangle brackets, IM end, IM being instant message. So it's kind of like a pretend instant messaging app. This is the message from the system, this is the message from the user, this is the message from the assistant. So why have this weird IM start with triangle? Is because that's much less likely to appear in the user's actual query. And so that's why we're picking something a bit obscure, and that way we can just, cut off the response when we see it. So the point of this was that then once we had a standard format, people started to collect lots of prompt response pairs. So we said, let's make up a data set of 1,000 prompt response pairs. So we'll give you a prompt always in this format, 3 hashes and instruction, and then response. So it'll be like, hey, what's the weather like? It answers something. It says, hey, compute 2 + 2. It answers something. And so we came up with these 1,000 pairs or 100,000 pairs, depends on the company and people doing this. And then we trained the model further. The model that we already had, the space model that people spend millions of dollars or $100,000 training, we trained it further on this narrow way of formatting, a narrow way of prompting, where the model always saw these triple hashes and then instruction. And so it really got adjusted itself to the style of how these models work. And that's the process of fine-tuning. That's when you get the fine-tuned models. And what are we fine-tuning for in this case? Instructions. We're giving instructions and it follows instructions. That's why it's called instruction-tuned models or instruction fine-tuned models. And so now we have a model that just knows to answer questions well. So for example, now, by the way, you see big enough text, start header ID. It's basically the same thing as the previous one, IM start, but everyone has to come up with their own format for some fucking reason. So we got this one. So this is the latest Llama 3 model. It's very cool, but that's their format. And so they're following that format. The real key parts are the system messages saying, hey, you're a model that always answers helpfully in Markdown, which is the format. And then the question from the user, which is here, is define user experience, which is the UX design thing. I guess, yeah, obviously. So now we're going to say question, and actually gives me an answer. None of that autocomplete stuff, it just gives me the answer. If I go to a different query, classify the sentence of the movie, and I ask it, it just does it. It's negative, here's an explanation. If I say, you know what, only answer with one word, positive or negative, I do that, answer with one word. And so now this model, the one Llama 3 8 billion instruct, unlike the previous model, the base model, Llama 3 8 billion, is already been fine-tuned by Meta to follow instructions. So you can now use it for actually interesting tasks to say, hey, take this grocery cart and add up the prices, or take this thing and give me some suggestions about it, as opposed to like having to pretend like this is a document situation, like here's what you should complete. So because they already trained it. Please.
So this is how they tune the model, and now the model you use is just completely normal language.
Yes. So that's exactly. So basically, this is the insight on top of the language models of Future Learners paper that allowed OpenAI to productize the GPT-4 model, the GPT-3 model into ChatGPT. So ChatGPT was an instruction-tuned model that was able to follow instructions, and that's why you had a chat interface. So you were able to like ask it questions as opposed to having to pretend, as I was saying before. So precisely, that's the key thing. Once you do it, you have a model that can now understand human language, and especially more importantly, understand human instruction, which should be followed by human response. AI response. So let's see, what am I trying to do here? That's good. Let's go to the next slide. Man, it's really nice when I have a lot of time to talk. I can like talk a little bit slower. Although I'm sure it sounds very fast to you guys. All right, so conversational AI. The same thing happens in conversational AI applications as is in instruction fine-tuning, which is instead of saying here's a question, here's a answer it, we're saying here's a question and here's a response that you gave me. I asked, can you help? And it said, sure, what seems to be the problem? And then I asked this. So really, in conversational AI, we're just copy-pasting your response or pretending that you responded with that and just sending that whole thing. So in this case, we have two messages from the user, one message back from the assistant, and it's going to complete that. We're going to copy that, put it up there again, and we can just keep adding that up. So literally, the user and assistant's messages are all just in this whole document or in this prompt. We're sending it forward and it comes back with one answer. This is literally everything that's happening in ChatGPT for the most part, at least like a year ago, where you simply copy the user's question into the thread, copy the assistant's answer into the thread. Now, of course, in this case, whenever I hit enter, it's actually doing this, copying this whole thing, sending it to my home computer, and then coming back. But in ChatGPT's case, they just save the messages on the server, so it's a bit faster.
So that would explain why there's a limit to how long a conversation you can have with.
That is an awesome thing to talk about, and I wasn't even going to talk about it, which is context length. So these models have gotten better and better and better at understanding or being able to process longer lengths of text because of the goals of us as a community guiding the process of the training. And as a result, we now have longer models, 32K lengths and 128K. But in the beginning, it used to be very much like 2048 words or even subwords, which is less words than that. And so eventually you would be like, my conversation cannot go longer than this. And then ChatGPT would be like, all right, start a new one. This model is tired. But that's why, because you just keep copying stuff into it. Eventually it'll be like, this is beyond my pay grade. So, as if it's getting paid. This is a slave. All right, the model. So just quickly about the conversational AI. This is something I want to highlight is that these capabilities are not coming from just, these capabilities are not just coming from the instruction fine-tuning, but it happens to be these models have seen so many transcripts on the web of people talking that it understands. Same thing as anything else. The things that these models understand are things that we put on the internet. So it might not understand certain concepts that no one has written about enough in life. Maybe some physical concepts are just like not represented well enough on the internet, so it doesn't understand them. But anything that people wrote stories about, physical concepts that are represented, or certainly emotional and story type concepts, it understands very well. So as a result, having seen so many transcripts, even the very base model where it doesn't understand instruction, you could pretend the following is a conversation between Andrew Yang and Andre Karpathy, who are two data scientists or basically AI engineers. And we just sort of say, Andrew said this, Andre said this, and we now ask it like, just complete this transcript. So basically gives us a conversation, and now we can use it as creative writing or just even like as a bot conversation. So if I say, UX conversation between Jordan and Alex interviewing someone for something, or if I say, hey, Dave is asking, Hal to do something, we can now simulate an alternative history of that dialogue because we gave it half the dialogue and then we said, just try and finish it. You can have a high temperature and it'll give us answers. So because it already understands these things, which is why the fine-tuning thing works. Because what I want to make sure you understand is that it is not as easy to just give it like more context and then fine-tune a model and just be like, oh, now it understands this. Now, fine-tuning is a very tricky process where generally speaking, you're more able to guide how it answers things and not so much like, what it learns and understands. There's a big debate about it like in the last year of like, well, is fine-tuning adding knowledge, is fine-tuning adding style? But the point is that this thing it's so good at, conversational AI, because the base model already saw so many transcripts in the world, so many interviews, all these internet places you can imagine, YouTube videos with transcripts as well. Which, by the way, OpenAI totally scraped up YouTube hardcore before they trained GPT. If you look at the face of that person in one of the interviews, he's like, yeah, what's going on? Please.
Just talked about fine-tuning, and I don't know if prompt engineering fits into that somewhere. Can you speak to that?
Great question, because prompt engineering and fine-tuning are two different things, but they're part of the same spectrum. Prompt engineering is when you're just guiding the model through examples to do something in that moment, stateless model. It'll forget everything after this. Fine-tuning is when you're basically using that prompt engineering ability that you just learned about giving examples. You have hundreds of thousands of examples of this, or thousands. You train the model further, which takes compute, and then now that model just knows. So now you don't have to give examples. So fine-tuning is simply just you have money and you have time to spend, and also you want to give it more context than just the one, few examples that you'll be able to give. So it is the spectrum. Prompt engineering is where you would start, generally speaking, with some use case you have, and I get a lot of value out of prompt engineering. But if something feels like you simply cannot do it without giving a lot more examples, then you would go ahead and fine tune. Another point on that is like if you want to use smaller models for some tasks, then it can help to fine tune those smaller models which are less capable of something, but the bigger model can do it by simply giving the smaller model more examples or giving hundreds of examples by fine tuning. So fine tuning is very helpful if you're trying to use the smallest possible thing for doing a bit more complex tasks. And some things obviously you cannot do with small models. But anyway, so structured data from unstructured data is my favorite use case for LLMs, which is a very constrained, pun intended, because there's something called constrained sampling. Basically something that can really easily be used and you can get a lot of value out of it. So for example, here's an application. Extract all the names and achievements and so on from this paragraph. Just a paragraph about different people doing different things, blah, blah, blah. Hit enter, comes back with an answer. Okay, pretty nice looking list, it gives me sort of broken down. But, it's useful, it's structured, but still someone's got to read it. I want it to be usable by a computer so they can process it. All right, well, you guys all know this. Let's ask for JSON. Or maybe you don't all know this, but JSON is simply a format that a computer can understand better than natural language. So now I'm going to say, give me that answer, but actually, you must answer using the following JSON schema. And so I'm giving it the schema where it has like, name, location, achievements, and I'm going to hit enter. And now it's actually going to give me a JSON format, which is incredible. I see the face, I like it. That's the excitement that I had. Which is now you can actually ask it for computer data, JSON. You can immediately use it. And you're like, yeah, okay, I get it, but I'm going to show you an immediate way to experience how cool that is. Where actually I'm going to ask for the persons, but I'm going to then pipe it into a user interface that I created, so it dynamically shows that information. So now if I ask it, this goes into a UI directly. So this is where you can have a lot more interesting user interfaces where you don't have just reading text all the time, right? You can have another example of this. I have, hey, give me all the attractions in San Francisco. But again, I'm going to make a UI out of it. So as it comes back, streaming, it shows me with these tags, with whatever, it's a landmark, it's a historical site, everything just works beautifully. I'm going to ask, yeah, go ahead.
Just a quick question. Are you still Llama Instruct when you're doing this, or have you switched?
Yes.
Okay.
Great, yeah, great question. So this is the instruct model, because I'm giving it not only instructions of what to do, but how to do it, give me JSON only. It seems like a pretty instruction-heavy task, so instruct model is what I'm using. And the Llama 3 8 billion, by the way, is beating GPT-4 from last year, which is beautiful, because now you don't need OpenAI for anything. And so, yeah, you had a question as well.
So you also code how the UI should look?
Yes, so actually, yes. No, so in this case, the data comes back as JSON, as I was showing, and then I'm using that JSON in my this whole thing is a Svelte app, by the way, and so I'm just using like my own Svelte components to display this thing. What you're talking about is asking the AI to actually write the UI code. I'm very fond of that whole idea as well. I'm working on certain projects to build that. That's generative UI. I don't talk about it in this talk, and I'm sorry, my mic is always like this. But anyway, you had a question as well.
Yes, sir. Second question. I noticed that you're using the triple tick JSON in the prompt, and I often get that in, this might be too niche. I get that in like,
GitHub
the
Copilot.
outputs
Yeah.
as a response. response oftentimes when I wanted to just use JSON. So I actually haven't seen that prompting technique. Is that they were trained to respond with JSON with a triple tick JSON?
All right, just because you're asking this, I'm going to totally talk about it. I love this thing, which is what I'm doing here is constraint sampling, which is basically not just begging the model. There's not really a please anywhere in this prompt. There's a lot of people just don't know shit, and they're all like, please don't do this. My boss will cut off my fingers. All this shit, right? Just blackmailing the model. You don't have to do any of this shit. There's something called constraint sampling, where you're basically biasing each token as it generates to be the valid token only. And so you're basically giving it this schema, not just here in the prompt, but also you see another one, I'm copying the same JSON schema here. And this JSON schema I'm using through code to actually enforce that output. Now, because you guys are, the people actually already know how probability distributions work, because I explained it. So when it has that probability distribution of answers that come back, let me go back to this slide. Then actually it'll say, unless the token happens to be an open square brace, simply rejected. Or, well, it'll be one of the tokens, right? Because the whole vocabulary is there. So only accept the square brace for the very first token. After that, only accept the open brace, this thing. After that, with the code, only accept name as the output. And so it happens to bias the result towards the only thing that is acceptable to us. And you might be like, how will it know the square bracket is the first thing? Well, these are just computer engineering, problems. We know that if we're asking for JSON and it's a JSON array, we know that that'll be the first token. So we've biased the first three tokens to be that, and that. And then also name a word we biased it. So it's the constraint sampling is why we don't have to beg it, and that's why it won't come back with like tick JSON.
What part of the prompt is enforcing the constraint on a model that doesn't have like JSON mode or something?
Yeah. So that's a good question because the model is not doing that. Software that I've written on top of it is doing that. And in this case, the library that I'm using eventually integrated that feature within itself. So now I don't have to write more code on top of it. And the engine that I'm using, if you're interested, is called VLLM. Look up VLLM on GitHub, and you'll be able to run a Docker instance yourself, which is what's happening in my own
computer. So it's not the
computer.
triple ticks in the prompt that's enforcing that, you have an extra layer?
Absolutely, yes. Cool. And so structured data, not just about, I should have already mentioned this earlier, but JSON is not the only thing. You can really bias it towards anything. And one of the coolest things that you can do is bias it towards regular expression matching. So I'm saying, you know what, here's a bunch of movies, and go ahead and clean up the list so that the runtimes are always in a given format. Because look at this list. This is from Wikipedia. 142 minutes, 2 hours and something, 2H, 32M. Very annoying. Like a human would take forever to do it. Same thing as a computer if I were trying to do it. But this is exactly the kind of task where an LLM would understand the concept with simple numbers, and it'll be able to give back a structured list. So now if I say, only give me XYZ hours in ABC minutes format, and then I'm also having a regular expression query right here, which is enforcing that. So after runtime, you have to have a digit, for length of 4 digits and so on. Now I'm gonna ask it, come back, and it's gave me, 2 hours and 22 minutes, 2 hours, 5 minutes. Beautiful. Now you can imagine you can take this response, give it to another prompt, and say, give me JSON out of it, and then you golden. Now you can use it into a UI or put it into a UI. So, yeah, a lot of concepts getting very close towards embeddings as well, which is tool use. So now that you understand structured data and how you can just enforce JSON, which means you can really start using it for computers automatically. JSON is simply, just pipe it to a thing and it'll use it. Now you can do something like tool use. So you just give it all these tools. You say, hey, here's the JSON schema, get current time, get current date, get current weather. These are all just tools that I'm giving it, and I'm saying, what's the time right now? Now it won't give me the time because I'm saying only give me the actual tool I should call. So, because if you give me the time, it'll be wrong because it doesn't have the real world knowledge. So now if I say, give me the time, it'll say get current time is the function I want you to call. It's a tool call, right? So this is beautiful. But now we have got the model to behave as a router. It's simply taking our calls and picking which tool it should use. That's a very powerful thing. This is the kind of thing that AI agents use. I'm pretty sure Nurain is going to talk about it at length, and I'm very excited for his talk. And so this is the kind of thing where now once you have tool use, you can just go nuts with the kind of automations that you can do. So if I say, what are Tesla and Apple stock prices, it'll call the get value of stock function. But because it's smart enough to know Tesla's ticker is TSLA and Apple's is AAPL, that's the kind of knowledge you extracted out of the model that you did not have to give it yourself. But the other stuff is it's using what we told it, get current value of stock. And I have a bunch of other examples about shopping lists, bananas, and so on, but I'll be mindful of time and move on to the latter concepts. Embeddings, which is basically the last big topic. Extremely awesome things. You basically what embeddings are is these models you train these models to understand to hash a given string, to basically convert a given paragraph, line, entire page into just a point in space, a high dimensional space. You can imagine it as a physical space, 3D, but it's just a high dimensional space, almost like a 1,000 dimensions and so on, sometimes 4,000. And what happens to be, because of the training process that they go through, happens to put similar concepts in similar neighborhood, which is incredible. So that means if I have these sentences, I'm developing an app for the Apple ecosystem. I'm setting up a home media server, Raspberry Pi, and so on. It's going to go ahead and cluster them, or not really cluster them, but just put them in that space. And the space that these two sentences end up in, I'm setting up a Raspberry Pi and I'm doing a gaming console, happens to be close. That's incredible. They're actually physically close. Now, you might be like, well, this is a 2D graph. How did you get into be like circular? Isn't it like 1000D space? It's because we're doing some simplification by this process called PCA to visualize it, but it does try and maintain what this looks like in that high dimensional space. So these are all related to the Apple, the company, and this one is related to Apple, the fruit. So it's clever enough to understand the word is not the same. The context matters. And so Apple and Apple Floating are here, while Apple MacBook Pro is over here. So this is an incredible concept because now you can actually say, go, from here, just walk around, find your neighbors. And nearest neighbors is another concept I'll talk about now. So if I, for example, in this case, I have done this, I've created a database, a vector database, and just a database in general by scraping Wikipedia, IMDb, TMDb, a bunch of scraping going on, and just create like a movie database of like 100,000 movies. I'm going to say, go ahead and take this string that I've written. A hacker discovers his reality is a simulated illusion and joins the fight against oppressive machines, which probably sounds very familiar what kind of movie you're thinking. And just put this in that space, high dimensional space, and walk around it, see what are the nearest neighbors. So I'm going to ask. It says Hacker Wars. It says Matrix. It says, well, you guys are probably thinking Matrix, and Matrix is one of the neighbors. And it's important to understand it's not actually matching the description that I wrote to the description of the movie. That's not what's happening here. It's putting this description in a point in space, and just happens to be, because of the mechanism that embeddings use, that around that space, the nearest neighbor was the Matrix, which is awesome. And so, for example, I can say the same thing, families descended to mafia underworld, loyalty and stuff, and one of the movies that it picks is The Godfather. So this is the kind of thing that you can build search engines for products and so on based on not just keyword, not just filters, but also semantic search. So you can say, give me blue jeans with tears in them and so on. And you can use also photos and stuff, which is a whole other thing that I never get into these talks, and I will eventually be. I'll talk about the things that I'm doing upcoming in a moment. But yeah, so finally, putting it all together. I should probably call this putting it all together, but RAG is a pretty big word. So retrieval augmented generation is the key sort of big use that people are exploring. I would say structured data from unstructured is a bigger winner. But RAG basically means you're saying, given a question, like what are the key similarities between inception and tenet, actually I'm going to give you the context. What is inception, what is tenet, or some details about it. And so then you can actually bias your answer to the context that I gave. So now if I ask for it, this thing always goes wrong. One second. If I ask which actors played key roles in Dimension movies, and then I just give it the context by myself pasting Inception's description and Tenet's description, and I ask for it, it'll go ahead and give me the answer. Why it's not giving me the answer, don't worry about it. But this means that if, for example, you had the tools before, you would say, which movies did I ask about, Inception and Tenet? Okay, cool. Let me look up the description of Inception by saying get movie description with the word Tenet, get movie description with the word Inception, copy that into the prompt, use the following context to answer the query. So you're saying, hey model, only use the following to answer the question, and it's going to do that. Let's see one more try if this one thing works. All right, it works. Good. So that's really, there's a shit ton more in this concept of RAG, like how to do it properly, how to get good answers, because this is just how to get answers. Good answers, that's where engineering comes in, and I'm going to be talking more about it in forums up ahead. Primarily, I'm going to be talking about these things in my workshops that I'm doing upcoming, all free always. And so if you want to join, connect with me on LinkedIn and stuff. But for now, that's all. Cheers. And yeah, that's my LinkedIn QR code, and I have like my workshops posted over there. Yeah, if they're like waitlisted or something, then just like fill up the form, and I'll let you guys know when the next one happens. Oh, questions? Everyone's shy now.
That seemed like a lot of information to absorb. It was like prompts and prompts and prompts.
Fire hose.
And I'm like, there's so much information you have to put in. It doesn't seem so intelligent.
I agree with you completely. You're basically my friend now because these models are not very intelligent. My whole thesis is like, don't treat them like gods. Treat them as these tiny little machines who do tiny little things when you guide them just right, and then test them out. I didn't talk about evaluation. There's many ways to do that, but that's really my core thesis. Like, just use them as like these tiny things. Like, use them like Docker. Use them like JavaScript. Use them like computers and power outlets. Don't treat them as these things that can just like buy your groceries for yourself.
But there's so many things to use these days, from ChatGPT to Gemini to all the different platforms out there now. So it's trying to figure out which ones will give you the most accurate and beneficial results.
I think what you're talking about is the larger sort of user assistant space where you have these bots like ChatGPT or Gemini's model facing consumers and they're looking for answers. I think the claims that they make are broad and unfounded. And so that's why people get disappointed when they use these applications and it doesn't answer their questions. My point is the opposite. My point is like, no, as a developer, as a designer, building out an application, if you're looking for food items that are matching a certain type of food, or you know what, I say strawberries and I say find around the nearest neighbors. What are foods that I might like based on the embedding space? That's a very small little limited case. Not, hey, buy strawberries, or are strawberries healthy for me in my own condition? Very complex questions, go to a doctor for that. But I think as a developer tool, to say when the user's request comes in for adding stuff to the grocery cart, then I see, okay, actually they ask for 2 bananas and 3 apples. All right, I'm going to say add item to grocery list. That's the function. The parameters are bananas, quantity 2, apples, quantity 3. Very small use case, but now you can do it within AI, right?
So lots of work.
Yeah.
Just to add to that, is there any complexity, like finding a fruit is pretty simple, but if I want to create embeddings about all of my work, like all the emails I have written, and basically then ask to, so if we make that complex space, how does that vector database find more constraint or more complex scenarios and find relevant information?
Yeah, no, that's exactly the question. Like, I'm showing you somewhat contrived examples, probably very contrived examples, and you're like, okay, can I do anything actually useful with this, or am I just asking for bananas and apples? You can, but my point is that you have to really work on it. You can't necessarily just say these models are good enough, even if Gemini says I'm great, or OpenAI says I'm great. Gemini has open source models as well. Google has called Gemma and so on. Try them in a small capacity. So if you can break your problem down, that's a complex problem of like, given, I was working on a project with a friend, having to analyze literature journal like of medical studies and getting data out of them. And it's not as easy as just saying, just look at this document and give me an answer. No, there's a lot of work you have to do to guide it. You know what, you're only going to find this kind of answer with that. You have to tell it. Generally speaking, people put this kind of information about the cures that they explored in this kind of context and so on. So you really have to guide. So if you can break the problem down, that's a better version. If you can say, I'm going to say, extract the name out of this document, extract the number of patients they work with, extract this thing, and these are separate calls, and you give it lots of context, and you give it training, then you're going to be much more successful that way. But if you say, summarize this document for me, and do a great job, it's going to be tricky.
Is that concept called chunking?
No, that's part of the conversation, but I'm giving you more of a high level overview.
Very excited to go to all your workshops, so thank you for this. As far as the triple tick, using as a delimiter in your prompting, again, maybe a bit too niche for the timing right now, but so feel free to defer. But it seems like you're using it a lot. Is that a llama specific behavior? Because I'm having a lot of success with XML tags in other models. I don't use llama right now very often. So
Yeah.
I know llama's prompting format uses a lot of XML tags as part of their own prompt structure. So maybe that interferes, and that's why the triple tick's a good delimiter. I'm just trying to
No,
sort that
so
out.
so just very quickly on that, you guys may have noticed these things like triple tick MD and triple tick JSON. This just happens to be how software developers have for a long time delineated code in the markdown file format. So happens to be that these models have seen lots of examples of it, and as a result of it, I'm just like trying to get into the model's comfort zone, and that's why I'm giving it backticks. You've also seen XML, and XML happens to be another comfort zone just because it's seen it a lot.
Yeah.
Anything it's seen it a lot, it'll end up, maybe there's a specific format that Reddit uses and it might have seen it a lot. You can try and emulate that. But I think it's basically called out of distribution and within distribution. And if you're staying within the distribution of the model where it actually has seen it a lot, you're going to get a lot more success out of it.
Llama specifically just seems like an interesting example because they use XML within their own prompt structure.
Yes.
So there's
Yeah.
internal consistency that this feels like it plays with a lot better.
Perhaps, yeah. I think that's a question to explore. And I'll stop in a moment, which is last question.
So once you finish like tuning the model, and after that, if the core like model has been updated, how do you keep the tuned model?
That's a great question. You don't. These things are very hard to train. Also, I mean, these take a long time to train. You have these thing called checkpoints. So as you're training a large model, like the base model, the 8 billion, with 15 trillion tokens, you'll have every week or every day or every hour like checkpoints. So you can restart at some point, but you can't really merge and mix quite in the way that you would think. Although there is a whole field now called model merging, and the crazy amount of like fun stuff is going on where they take like a llama model and a Mistral model and try and like smash it and like cut stuff and so on, and it still performs, and it's very cool. Look it up. Something called MergeKit. I can learn about this for hours, but I gotta respect Nuren's time and hand it off to him. Thank you so much.